The written problem is a projectile motion problem where a ball is thrown from an initial height of 5 meters with a speed of 34 meters per second at an angle of 57 degrees above the horizontal, follows the path shown in blue, and strikes the ground over here. From this picture, we can write down what do we know about this object. We're told that its initial height is 5 meters. The angle is 57 degrees. The initial speed is 34 meters per second. And the final height, because it strikes the ground, is 0. Part A asks us to find the initial velocity components of the ball. We can find these using sines and cosines. The x initial velocity can be found from our initial velocity multiplied by cosine theta, and the y initial velocity can be found by multiplying the initial velocity by sine theta. Plugging in the numbers for each, we get 18.5 meters per second for the x initial velocity and 28.5 meters per second for the y initial velocity. In part B, we're asked to find the time at which the ball strikes the ground. We can solve this using a kinematic equation. We're given information about the final height, initial height. We just calculated initial y velocity, and we know the acceleration is due to gravity, so t is actually our only unknown in this problem. If I were to substitute in the values that I've been given or calculated, I'd have 0 equals y naught, which I know, v naught yt, which I just calculated, and then negative 1/2 gt squared. This is a quadratic equation in t. So to solve this, I'm going to want to use the quadratic formula, which says t is equal to negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a, where in my quadratic, minus gt is a, v naught y will be b, and y naught is equal to c. We can plug in these quantities into the quadratic formula, giving negative v naught y over 2 times minus 1/2 g plus or minus the square root of v naught squared y minus 4 times a, which is 1 minus 1/2 g, times c, which is y naught, all over 2 times a. We can simplify this and plug in our numbers to get 28.5 over 2 times 1/2 gives us 1, so it's just g in the denominator. And these two minus signs cancel. Plus or minus the square root of the value for vy naught squared. Again, our two minus signs here cancel, so this will be a plus. 4 times 1/2 gives 2. And then for g, we have 9.81, and y naught was equal to 5. The denominator is still 2 times negative 1/2 g. 2 times 1/2 gives us 1, so this will just be 9.81. I'll erase the units here just because I left them out for all of the other numbers. We don't need to worry about this minus because this is actually a plus or minus, and so it will get absorbed into that. Figuring out the two solutions to our quadratic formula, we get t is either equal to negative 0.17 seconds or t is equal to 5.98 seconds. Time can never be negative, so this can't be the answer. And so the time the ball will stay in the air is therefore equal to 5.98 seconds. Part C asks for the x position of the ball when it strikes the ground. X motion for projectile motion can be found as x, the distance traveled, is equal to the initial x velocity multiplied by time. We just calculated the time in part B, and in part A we found v naught x. So for this one, we just need to multiply our value for v naught x that we found above by the amount of time the ball travels in the air that we just found to get that the horizontal distance traveled is equal to 110.6 meters. The last part asks us to find the y component of the velocity of the ball when it strikes the ground. We want to solve for y velocity, so we can use the last kinematic equation that we haven't used yet in terms of y, where negative g is the acceleration. We found initial y velocity above as 28.5 meters per second. We know the value of g, and we calculated the time in the air in part B, so we actually know everything here and just need to calculate it. Doing so, we get that the y velocity when the ball is just about to strike the ground is equal to negative 30.16 meters per second.